Today in Capechi's Corner, we're going to look at other angles in a circle. Our first theorem states that the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measure of the intercepted arcs. So for instance, in our example, if I have x and y are intercepted arcs that are formed by chords and angle 1 is in the center of that circle, I'm going to add the measurements of x and y, divide by 2, and that will give me the measurement of angle 1. So in our example, our arcs have a measurement of 110 and 150. So if I add them together, divide by 2, so I get 260 divided by 2 gives me 130. So that's the measure of angle x. The biggest thing here, remember, is if the angle is inside, we're going to add the intercepted arcs and then divide by 2. Our next theorem has a similar idea, except for the angle is outside the circle. So the theorem says the measure of an angle formed by either two secants, two tangents, or one of each, a secant and a tangent, drawn from a point outside the circle is equal to half the difference of the measures of the intercepted arcs. So our first example here, we have two secants. So again, because the angle is outside the circle, we're going to subtract and divide by 2. So in our example here, x is the farthest arc away from the measure of angle 1 there, so that's going to be our bigger arc. So we're going to take x and then we're going to subtract y, divide by 2. So in our example, our two intercepted arcs have a measurement of 85 and 25, so we'll subtract them. 85 minus 25 gives me 60, divide that by 2, and then we know that the measure of angle 1 is 30 degrees. So again, if the angle is outside, we're going to subtract the intercepted arcs and divide by 2. Now we're going to look at the same theorem, but this time we're going to be looking at two tangents that are forming the angles. So I have angle x and angle y. Because angle 1 is outside the circle, we're going to subtract them, divide by 2. Now, if we look at our second example here, I know I'm only given that one intercepted arc is 275. So I don't know what this other arc is here, but I know that the measurement of a circle all the way around the degrees are 360. So I'm going to take 360, subtract 275, and I know that this arc has a measurement of 85. So I'm going to take 275 minus 85, divide by 2, and that tells me that the measure of angle 1 is equal to 95. As we continue to look at that theorem, this time we have one secant and one tangent. So in our first example on the left, again my angle is outside the circle, so I'm going to take my intercepted arcs, x minus y, divide by 2. So in my second example, my arc that is farther away from my angle is 165. Subtract 60, divide by 2. So I get 105 divided by 2. So the measure of angle x is equal to 52.5. Let's look at some examples now. So it says find the value of x. So our first example says that our one intercepted arc is x, and our other intercepted arc has a value of 46, and our angle outside is 28. So I know I have to subtract my intercepted arcs. So I have x minus 46 divided by 2 is equal to 28. Now how did I know that I put x first? Well, it's the farthest arc from my angle. I'm going to cross multiply, so I have 56 is equal to x minus 46. Add 46 to both sides, and x has a value of 102. In our next example, in number 2, I know that my angle outside is 65. My one intercepted arc here is x. I don't have a measurement for this arc outside, but I do know that the whole circle has a measurement of 360, so I know that that intercepted arc is going to be 360 minus x. So I'm going to take my intercepted arc that is farthest from my angle, which is 360 minus x, and then I'm going to subtract this x, my other intercepted arc, divide by 2, and that gives me 65. So when I clean things up and cross multiply, I have 360 minus 2x is equal to 130. So negative 2x is equal to negative 230. So x has a value of 115. In our last problem today, we're going to look at this big circle. There are a lot of different angles in there. We have chords, we have tangents, and we're going to find the measure of each angle. We're not necessarily going to go in order. The information we're given is this one arc BC has a measurement of 90, arc CD has a measurement of 30, and arc DE has a measurement of 20. Now the first thing I want to do is I'm just going to continue in labeling my arcs. I know the top part of this, I know AC is a diameter, so I know I have a semicircle. So I know this arc has to be 90. And if I look below, I know arc AEC is also a semicircle. So I have 30 and 20 gives me 50. So I know the measurement of this arc right here is going to be 130. So I'm going to label that, and hopefully that will help me along the way. Now it doesn't really matter where you start. There's a lot of different options. Obviously, you need to make sure that you're confident in what you have. Because this arc has a measurement of 90, and this is a central angle, I also know that measure of angle 1 is 90, so I'm going to fill that in there. Now, if I look at angle 3, that's an inscribed angle, and the intercepted arc there is 50, so I know that has to be half of that. So the measure of angle 3 is 25. Now, when I look at angle 9, I have a radius and a tangent, so I know that that is perpendicular. So measurement of angle 9 is 90 degrees. If I look at angle 10, that is also an inscribed angle. We have the tangent and we have a chord, and we're using this 90 degrees and 30 degrees. So that intercepted arc has a measurement of 120, and so the measurement of angle 10 is going to be half of that at 60. If I look at the measure of angle 2 right here, and if I'm looking at the chords, chord EC and chord EA, 2 is an inscribed angle, and that's meeting the diameter. So that's a semicircle, so I know that the measure of angle 2 is equal to 90. I know angle 7 is outside of the circle, and that's formed by 2 secants. So the intercepted arcs I have 90 and I have 20. So 90 minus 20 gives me 70. Divide that by 2, and I get 35. So the measure of angle 7 is 35. Now, in looking at the measure of angle 8, when I try to figure out what that is, and I could do this a number of different ways, I know that the measure of angle 9 is 90, and I know that the measure of angle 10 is equal to 60. So I actually know that this has to be 30. So now I'm just using that triangle inside. Angle 1 is 90, and then this other angle here is 30. So I know the measure of angle 8 has to be 60. Now, I could have also used some intercepted arcs and added them and divided by 2, but there's just one way to do it. Now, in keeping with angle 8, I know this angle right here is a vertical angle, so that's going to be congruent. I don't know if that's going to help me later, but I'm going to try to work with that. And then I have angle 5, which is right here. Now we're getting a little tight. So I have one intercepted arc, has a measurement of 90 again, and the other intercepted arc is 20. So that's inside the circle. So 90 plus 20 gives me 110. Divide that by 2 and I get 55. Now if I'm looking at this little triangle, it's kind of tough because it's so tight in there. But I know that one of the angles there is 80. The other angle, measure of angle 5, we know is 55. And I know that triangle has a sum of 180. So to find angle 4, I just subtract what I can. And again, the measure of angle 4 is going to be 65. Now again, there's more than one way I could have gotten there. That is an angle, an inscribed angle, so I could have gotten there a different way as well. Now my last angle is angle 6. Now we said angle 5 is 55, and I know I have a straight angle here. Right here is a straight angle. So if I take 180 minus 55, and I know the measure of angle 6 is 125. Now, a lot of these I could have gone in a different order. I could have even found the different angles in a different way. So again, you just need to make sure you know the theorems and the corollaries that go along with circles to complete this problem.